This video will discuss the amount due on an annuity. So the amount due is referred to payments that are made at the beginning of each period. Find the amount due on an annuity if $2,500 was deposited annually at a rate of 3% for 12 years. We're asked to find the amount due. That means we'll use this formula for future value. Notice that this formula is very similar, but the exponent is n plus 1 instead of n. Also, once we find the future value, we need to plug it into the formula here to find the amount due. And we'll use AD to represent amount due. So first, we'll identify the values for P, I, and N and plug them into our formula for future value. Next, we'll plug the value we find for future value into our formula to find AD. Our value for P is $2,500. I is 0.03. And that's because we're compounding annually. So I would take 0.03 divided by 1, which just gives me 0.03. And then n, which is the total number of compounding periods, is 1, since we're compounding annually, times 12, which is just 12. So we'll take those values and plug them into our formula. Once you plug them into your formula, you will do the parentheses first, which is 1 plus 0.03, and that gives you a value of 1.03. Next, we'll add the exponents together, so 12 plus 1 is 13. In our second step here, we'll take the 1.03 and raise it to the 13th power. You should get a decimal of 1.468533713. Keep that number in your calculator and then just push -1. So you should get 0.468533713. Now keep that number in your calculator and divide by 0.03. And we should get 15.61779043. Now, if your decimals are a little off at the end, if they're off by 1 or 2 places, that's okay. You should still get the final answer when we round to 2 decimal places. You might just have different decimal places at the very end of these long decimals because your calculator may round or carry more digits than mine did. So you should still get the same final answer when we multiply by 2,500 and round to 2 decimal places. So when I do that, I get a future value of $39,044.48. Now this is the future value. We're not done with the problem yet. We want to take the future value and plug it into our formula, and then we'll find the amount due, which is our final answer. So the amount due equals $39,044.48 minus $2,500. When we do that, we get a final answer of $36,544.48. And that is the amount due on the annuity. If $1,400 is deposited at the beginning of every month with an interest rate of 6% compounded monthly, find the amount of interest earned after 5 years. For this problem, we're told that the amount is deposited at the beginning of every month. That means that we're going to use the future value formula for the amount due, which is listed here. Now we're also told that we want to find the amount of interest earned. So first we're going to find the future value. Once we find the future value, we can plug that in to find the amount due. Once we find the amount due, we can now plug that into the formula for interest earned. And this will be the final formula that we'll use that will give us the final answer. First, we want to identify the values for P, I, and N. P is 1,400. I is 0.06 divided by 12 since we're compounding monthly. N is the total number of compounding periods, so we take compounding monthly, which is 12, and multiply it by the number of years, which is 5, to give us 60. We'll take these values and plug them into our formula for future value. So once you plug those values into the formula, you should get these calculations. First, you'll add 1 plus 0.005 in parentheses and get 1.005. Next, you'll add the numbers in the exponent position. 60 plus 1 is 61. Now, you'll raise 1.005 to the 61st power, and you should get a decimal of 1.355594403. Keep that number in your calculator and put -1. You'll get 0.355594403. Keep that number in your calculator and select the division sign and then 0.005. Now we have that the future value equals 1,400 times 71.1188806. Now multiply that number by 1,400 and round to 2 decimal places. So we have a future value of $99,566.43. Next, we're going to take that value and substitute it in the formula for the amount due. So the amount due equals $99,566.43 minus $1,400. And that gives us a value of $98,166.43. Lastly, we'll take that value and plug it into the formula for interest earned. And that will be our final answer. So I equals $98,166.43 minus 60 times 1,400. You'll do the operation within parentheses first. So 60 times 1,400 is 84,000. Next, you'll subtract to get a final value of $14,166.43. And this is your interest earned. And this is your final answer.